Good morning, everyone. Can you hear me?
Yes, I hear you.
Good morning, everyone. My name is Amran Sharaf. Good morning to our colleagues in the US, and good afternoon, I guess, to our colleagues in Europe, and good evening to everyone in Asia. Thank you very much for having us here. My name is Amran Sharaf, and I'm the project director of the Emirates Mars mission, which is also known as the Hope Probe mission. Today, we thought we were going to share with you some detail and updates about the mission, given also the current situation with the COVID-19 and where we're standing today with regards to the launch. Can we go to the next slide, please? So, what's unique about Emirates Mars mission compared to other outer space exploration missions is that usually in other outer space exploration missions, these missions are focused on the science questions, and the main driver behind it are the science questions. In our case, actually, the UAE government wanted to use Emirates Mars mission as a catalyst to expedite the development in our science and technology sector, to create a big shift within the Emirati youth when it comes to their perspective and interest in STEM, and also to create an impact at a regional level, a region that is going through difficult times. And it's just a reminder to the Arab youth is that if the UAE, a country that's younger than 50 years old, less than 50 years old, is able to reach Mars, then you guys can do much more. It's an example of a collaboration. It's an example of coexistence in which we have the team in the UAE working with partners from different parts of the world to make UAE reach Mars. And one of the objectives that was set by the government also is to celebrate our 50th anniversary with a big achievement. All this has to be done through novel and unique science that serves the international scientific community. So it's not about just reaching Mars and about answering our scientific questions, but also it's about creating a big impact within different sectors that we have in the UAE to be able to build our science and technology sector, to be able to push our young generation into sciences, and strengthen a knowledge-based economy, a post-oil economy. So the challenge is not just reaching Mars. The challenge is about changing mentality also. So this was all part of our program that started in 2014, and a lot of developments and things happened since then, in which we've seen a big shift in our academic sector, in which we were able to engage with industry in the UAE and get them involved in our project, get SMEs involved. We saw students shifting from different majors, we saw students who were studying international relations who went into sciences because before this mission, they didn't think that there was any interest from the government when it comes to sciences. Scientists had very limited career path at that point, in which they either just taught in universities or worked in certain labs within the government, but very limited career path. But this mission showed them the path in which that basically scientists have also career path in the UAE the same way that engineers have, and also focused on the creating the research and development culture that we want in the UAE. So since the announcement of the mission, a whole ministry was set up within the country for advanced science. A science council was set up. We started seeing the UAE science community coming out and being part of the policy making process in the UAE. Next slide, please. So the Emirates Mars mission, or the Hope Probe itself, it's going to be about little over 1.3 tons in weight. It will carry 3 scientific instruments that will study basically the Martian atmosphere. My colleague Sarah Amiri will be speaking more about the scientific investigations and the nature of it. Basically, we'll be studying the relationship between the upper layer and the lower layer of the Martian atmosphere and the escape rates of hydrogen and oxygen. This was done in collaboration with our knowledge transfer partners. It was the first time that the UAE basically sent a mission to Mars. It's the UAE's first actually outer space exploration mission, and it's also the Arab world's first outer space exploration mission. So we don't have a lot of experience, and let's be very honest, Mars is difficult, Mars is challenging. So we had to learn from someone. So that's why the UAE decided to work with knowledge transfer partners in the US. Our main knowledge transfer partner is the University of Colorado at Boulder, represented by LASP, and also Arizona State University, who is our partner in one of our science instruments. We had a team that was an Emirati team that was based in the US that worked side by side with the US team and learning from them and significantly contributing in developing the mission. We had a team that was based in the UAE also that was working with their counterparts and their colleagues who were based in the US. And also we had a team from the US coming to the UAE, spending a lot of time working with the team and developing the mission. We have the spacecraft or the observatory is ready. The instruments, all three instruments are ready. The whole observatory went through an environmental test last year, which ended in December 2019 successfully. And also the spacecraft was shipped to Dubai, and we had different tests taking place in Dubai, which included the solar panels deployment, functional tests, regression tests, and alignment tests, and different kinds of activity. The plan was for us to actually to continue or complete these tests by May this year and send the spacecraft to the launch site, which is basically in Japan. We'll be using the H2A H2A launcher to launch our spacecraft. However, unfortunately, because of the COVID-19 situation, we had to expedite activities in Dubai, and we had to basically focus only on the critical testing and remove let's say, the additional testing that we wanted to do. Would have been good to have some of these tests, but basically we focused on completing the critical one, and the decision was made early on that basically we need to ship the spacecraft as soon as possible to the launch site, given the restrictions that came out with regards to traveling and having teams move around and getting them to the launch site in time. So it got too risky for us if we waited. And another thing that's unique about this mission is that usually other missions or outer space exploration missions that have been sent before, they're either launched by the country itself who's building the mission, or at least it's being launched through like, let's say, in a geographical location that country either has sovereignty over it or has a control over the launch site. In our case, no. The spacecraft had to leave like different parts of the world, US to Dubai to Japan. Involves a lot of traveling between the team that's in the UAE and also our partners in the US. So the team early on identified basically the need to go with or start operating under the worst case scenario, because we're talking about quarantine. So when you have a team member that travels to a certain location, they won't be able to join any activities after they go through a two-week quarantine. So early on in the project, we asked our colleagues in the US to send some team members to the UAE so that they go into our quarantine and stay in the quarantine for 14 days because of the COVID-19 situation. And in the meantime, the team who was based in Dubai was actually working, preparing the spacecraft for shipment. Once that team actually that was in quarantine, that came from the US, got out of the quarantine, that team that was working in Dubai was sent to Japan, and they went into basically a 2-week quarantine. So that by the time that they finish, once we ship the spacecraft, which is currently scheduled for next week, it actually they get out of quarantine and they receive the spacecraft, and the team that will be escorting the spacecraft to Japan or in the cargo flight, actually, they will be leaving the flight once they land in Japan and they go into quarantine. So this actually introduced another level of complexity. The mission itself was quite challenging. In 2014, when the government announced the mission, they said that they want to reach Mars before the 2nd of December 2021. That means the only launch opportunity before that date is basically in summer 2020. So we had only 6 years to develop the mission. So you're talking about a nation that didn't have capability at that point and experience in building outer space exploration missions. Our experience was based on Earth observation and telecommunication satellites. Had to come up with means and ways to be able to build that capacity and capability in 6 years, which is quite tight. The resources, when it comes to the budget, we have very limited budget. That will be announced at a later stage. And then basically also trying to create an impact in different sectors, changing mentality, brought with it other sets of challenges also. So coming to 2020, we thought we are actually now focused on the launch and getting the spacecraft ready, but COVID-19 situation took it to the next level. The good thing is that we were able to get the critical team to the US. We were able to get the critical team to Japan, and they're currently in Japan waiting. And then we have a team here in Dubai that will be leading with the spacecraft in the Antonov aircraft that's going to be taking the spacecraft there. And we managed to get all the approvals because currently the UAE also, the airspace is closed, the airports are closed. So we were able to get some exemptions and approvals from UAE government. And also with the Japanese government, there's a lot of restrictions for people traveling from the US. And also with regards also people coming from the UAE, there's extra visa requirements that were set on both UAE citizens and US citizens. So that was a very big challenge that we had to sort out within less than 3 weeks. But the Japanese government was very supportive and we were able to get that. So we got all the necessary approvals. Now the only thing that's left is to ship the spacecraft. The spacecraft is already unpacked. It's in the container. The container will be closed after tomorrow, basically on Sunday, and will be shipped to Japan basically Monday evening, early morning Tuesday. Can we go to the next slide? So as of now, we can say that we are on track with regards to launching the mission summer 2020. We're scheduled to launch, our launch window basically starts on 15th of July, and it's a 3-week launch window that we have. If you look at it from the US perspective, it's the 14th of July. And we'll be launching from Tanegashima. The launch campaign will start once the spacecraft reaches the launch site, which is basically within the next week. And we'll have basically about 50 to 60 days to prepare the spacecraft for launch. The whole launcher is dedicated for Emirates Mars mission. And the journey is going to take 7 months for us until we reach Mars. And currently we're scheduled to reach Mars early 2021 for the Mars orbit insertion. If you guys allow me, can we go to the next slide? So the next slide talks about the partners and the relationship that we have within the mission and how the team was able to deliver this mission given the limited resources that we had, especially when it comes to the tight time frame. This is the mission timeline. My colleague Sarah and Amiri should go into more detail. But can we go to the next slide? So basically, the organization that's in charge of executing, managing, and developing the mission is the Mohammed Barash Space Center. The fund that we have was basically given to us by the cabinet, and they appointed the UAE Space Agency, was tasked to fund us for this project. One of the things about the project, actually, because part of it was to create a sustainable out-of-space program. So our recommendation before the announcement of the mission was also to establish the UAE Space Agency. So one of the byproducts of this mission actually was the establishment of the UAE Space Agency. Before that, it was Mohammed Barash Space Center, but the Mohammed Barash Space Center is not a federal government entity. It's a local government entity. It's a Dubai government entity. So this is one of the things also was part of the impact that the mission had at the federal level. So we have different partners that we work with. So the idea was here not to start from scratch, but to start from where others ended and to learn from others. What we cared about the most was basically in working with our partners was that the partners had to have the same mentality as our team does and have similar organization culture that we have at the center. No, so we cared a lot about the individuals who worked in these organizations, in our partners' organizations. The mindset of the teams, the mentality, the know-how transfer, and the sharing of the knowledge was critical for us. As I mentioned earlier, the main partners for our spacecraft mission operation, observatory, and spacecraft INT was LASP at University of Colorado Boulder. Science partners is ASU, LASP, FSL at the University of California, Berkeley, LMD, Space Science Institute, same thing with instruments. Our navigation partners are Kinetics, and we'll be launching, as I mentioned, using Mitsubishi's H2A launcher. And if you guys allow me, I will be giving the floor now to my colleague, Sarah Al-Amiri, the science lead of the mission, who will be giving more detail about the science activities and the science questions and investigations of the mission.
Hello, everyone. Just a sound check. You can hear me? Yes.
Yes.
Perfect. Can we go to the next slide, please? Just to introduce myself, my name is Sarah Amiri. I'm the science lead of the Emirates Mars mission, and I'm here presenting on behalf of the Emirates Mars mission science team. As you can see in the slide until it goes on to the next one, it's made up of people based out of several institutions from the US, Europe, and also from the UAE. So the motivation behind the Emirates Mars mission science is covering the lower atmosphere of Mars throughout an entire Martian day and to sample it throughout all of the seasons available on Mars. And if we go back to the current MEPAG objectives, it maps on very well to Objective A with sub-objectives A1 and A4. And that has been the general motivation of the science of the Emirates Mars mission. Go to the next slide, please. The objectives are broken down into 3 different objectives from which we've derived 4 observations. We are looking to study the entire lower atmosphere of Mars and the weather dynamics throughout an entire Martian year, and to be able to better understand it throughout all times of the day. And the second science objective is to be able to correlate what happens in the lower atmosphere with rates of atmospheric escape, and to start to provide that correlation in conjunction with the current understanding of atmospheric space due to space itself. And finally, we are looking at the 3-dimensional structure of the exosphere of Mars, particularly focusing on hydrogen and oxygen, and that provides us the input also for the correlation with the atmospheric laws. Next slide, please. The instruments on the Emirates Mars mission are 3 instruments. All instruments, as everyone's aware, is installed. Exactly a year ago, one of our biggest challenges was to ensure that all the instruments were installed prior to entering into environmental tests. As Omran said, we thought that was our biggest hurdle and our biggest challenge ever faced on this mission, but it turns out that this entire situation that we're all living through turned out to be very challenging, and that logistics for once actually overpowered technical challenges. That being said, we have 3 functioning instruments that have been tested thoroughly, and on the spacecraft, we've got our infrared spectrometer in years, and we've got EMUs, which is ultraviolet, looking at our upper atmosphere. And EXI, because it's our first mission, is our imager on board that, and we do have a few using bands that we use the data that's collected from there in conjunction with EMIRS that is looking at our lower atmosphere. Next slide, please. This is a brief breakdown that gives us the science traceability and what are we looking in terms of constituents in both of our lower atmosphere and upper atmosphere, and how does that map into our instruments. To start off our first science investigation, and that's linked up to our objective A. Our first science investigation provides us with a three-dimensional structure of the lower atmosphere, a thermal state of the lower atmosphere, on a diurnal variability, and again, on a subseasonal time scale. So we get the temperature profiles from that for that investigation and the surface temperature for that investigation. That's received from Emirates. We also want to determine the geographic and diurnal distribution of key constituents in the lower atmosphere. So we measure water vapor column abundance, dust column integrated optical depth, ice column, and then also the ozone column integrated abundance. And I'll speak to some of those constituents when I'm talking about the instruments, because we have some data also with regards to performance. We can go to the next slide. Our third investigation looks at the thermosphere of Mars, and that's where we utilize the thermosphere along with a few models to be able to correlate the activities that are occurring in the lower atmosphere, changes that are occurring in the lower atmosphere with atmospheric loss. So we look at carbon monoxide column density and oxygen column density. We also want to determine the two-dimensional structure of the exosphere and get the hydrogen corona and oxygen corona. All of those measurements are being taken out of our immune instrument. Next slide. Now, for the orbit of Mars and why we're capable of capturing multiple times during the day at different geographic locations to be able to get that full image of Mars from a subseasonal timescale and also diurnal timescale across relatively all of the surface of Mars is due to the unique orbit that the Emirates Mars mission is in, or the whole probe will be in. At its highest point, it will be at 43,000 kilometers from Mars and 20,000 kilometers at its closest. Now, to explain how we'll be imaging or capturing data from this orbit, at our periapsis, we're sort of pseudo-synchronous with Mars's motion. So at this time, we'll be able to observe large parts of Mars at various times and various lighting conditions. And at our apoapsis, our furthest point, Mars will be rotating quickly beneath the spacecraft. And this will provide us an opportunity to take a global perspective for Mars. We get about 3 orbits per week. Roughly every 4 orbits will provide us the full data that we require on Mars' surface across different local times. And that provides us the diurnal coverage that we require, and also the diurnal coverage that we require across all of Mars. And that takes roughly 9 sols to capture, or 4 orbits. And with that, we're able to correlate data from our different instruments and start putting all of those together to be able to provide the diurnal coverage that we require. And then throughout the Martian year, when we're capturing that data, the data sets across the entire year, we'll be able to put out meet the requirements of having the subseasonal snapshots of Mars for atmospheric loss. Can go to the next slide, please. So, Emirates is an instrument that comes out of a large heritage out of ASU, and the test, some of you are aware of the test, mini test instruments that have flown to Mars and captured data around Mars. At the moment, from the current testing that has happened and from the data that has been captured from Emirates on the ground, it is providing us with the necessary data for us to be able to characterize the lower atmosphere of Mars. I'll talk more about this in EXI, but right now for our dust we are relying 100% on Emirates. Before, we wanted to add a UV band that we captured from EXI to those measurements, but still at this point we are confident that we're going to get the necessary data to be able to characterize dust in the lower atmosphere. Next slide. uses our far ultraviolet spectrometer, and it focuses on the spectrograph, and it focuses on the upper atmosphere of Mars, and it measures the corona. It takes images of Mars' corona at 3 different regions, and provides us hydrogen, oxygen, and carbon monoxide 4 PG band, and that provides us the understanding of both the thermosphere and the upper atmosphere. And as performance, again, to date, it is performing according to requirements and will provide the necessary data to meet our level 1 objectives. Next slide. Now for EXI, EXI visible channels are working according to specs and will provide us with a full understanding, will provide us with beautiful images of Mars, and also during dust storms we'll be able to capture nice red images of Mars to provide us with a visual on what's occurring there during that time. As for the science that we're getting out of this mission, the water ice clouds is entirely being captured, for the lower atmosphere, is entirely being captured by EXI. Ozone we are receiving from EXI, but we'll have a better understanding of ozone at higher latitudes rather than getting it across the entire globe, and that's with regards to the performance of this of the 260 nanometer channel. Also, dust used to exist before on this. We were targeting the 220 nanometer band for dust. At the moment, that band is providing us with a lot of noise, and it's a bit too wide for us to get any valid dust data out of it. And at the moment, we are not holding it as a required science band. Then again, these are data sets that we're going to download completely, and once we're in orbit, we can recheck the data. So in terms of the overall resiliency of our science and being able to capture the right data, we have the necessary data. We believe as a science team that we have the necessary instruments to be able to meet our scientific objectives and to find valuable scientific findings out of this mission. Next slide, please. So the previous slide just shows where all the instruments are. All of our instruments appear on one panel of on the instrument panel, or one panel of the observatory. The reason for that were several. One, we need to use Emir's, EXI, and somewhat EMU's data in conjunction, and therefore having them in the same place does work very well in being able to correlate all these different data sets from all these different instruments. And the second, it was important for us to be able to, because of the interest of time in terms of development, to have things available on various channels just in case something needed to be pulled out or access. The access to that is pretty fast, and that has been an overall design choice for this spacecraft due to the time. So with that, that's all I have, and I'm happy to answer any questions if there were any.
All right, thank you very much. Really exciting mission. We have a couple of minutes for questions.
Okay, we have a couple questions here in the chat window. First of all, would the presenters speak to their data availability plan?
Yes, sure. That's something I forgot. So, quick look data. So we get into orbit around Mars in February of 2021. Quick look data plots will be available for the first month of the mission in August of 2021. Level 2 data products, and I believe this slide has in the backup, or we'll at least make that available to MEPAG on the description of our data products, will be available in September of 2021, and that's for the mission orbit insertion, the first 3 months of the of operation. In December 2021, that's when you're going to get the bulk of the science data. So when we first arrive at Mars, we arrive at a capture orbit, and then we transfer into the science orbit. So the first 3 months of data will have a mix of both the capture orbit and the science orbit. The December 2021 will provide, again, the level 2 data products from data captured from May to July of 2021. And we will also provide what we're calling level 3 data products that are even processed to a higher level and allow scientists to derive plots directly, and that's from February to April of 2021. All of this, and then the cadence of releasing data after that, we're not holding on to data, so you'll get 2 months worth of data every 2 months. Sorry, 3 months worth of data every 3 months once they're validated and checked. If we don't need a lot of modifications to our data pipeline, then we are looking to reduce the time to have the data publicly available. That's an overall philosophy for the team, is to have the data publicly available to the public. There will be an Emirates Science Data Center that's being set up for both this mission, but more importantly for the long-term utilization of data across different missions that the UAE is working on, scientific missions that the UAE will potentially work on. And that will be at our normal website of emm.ae. I don't believe that website is up, but that's the website that we'll have there. And hopefully in future MEPAG meetings, we'll be able to even demo the Science Data Center of this mission so that people have access to that data.
Okay, this is Eileen, and I'm sorry we have to move on. There are several questions I know still in the chat window, so maybe the speakers can move to the chat window and answer some of those questions. So let's move on to the next talk, please.